In this second section of this unit, we're going to be talking about another way to solve right triangles, and it is using trigonometry. And trigonometry pretty much means trig means triangle, and metry means measure. In other words, it means the measure of a triangle. A trigonometric ratio is the length of the sides of a right triangle. Okay? So this is another way we can solve right triangles by using these ratios. We're going to talk about exactly what these ratios are here in this kind of second box. One ratio is called sine, and all sine is the opposite side. So you're going to be given an angle, and it's the side opposite that angle over the hypotenuse of your right triangle. Okay. We forgot an E. Hypotenuse. So how you go about creating a ratio is in this example, we're finding the sine of A. And the sine is telling you the type of ratio you're creating. And then right after sine, it has a letter or an angle measure. That's always going to represent an angle. So we're saying find the sine of angle A. Okay, well, we just said the trig ratio for sine was the opposite sine over the hypotenuse. Well, you start at the angle and go across with your pencil. We agree the opposite, like so. That's the opposite side. Right now, a letter is representing that side. Over the hypotenuse, we said in the last section is always the side across from the 90. And our letter that's representing our hypotenuse is C. So in this example, it's just the opposite side over the hypotenuse. For B, again, sine is telling us the ratio we're making, opposite over hypotenuse, and B is telling us what angle we're starting from. In this case, we're starting at B. So directly across from B, that's our opposite. And it's nice when you're dealing with the same triangle, the hypotenuse is always going to stay the same. So that's still our hypotenuse, the guy across from our 90. So the ratio for angle B would be the opposite over the hypotenuse. Okay, that would be a ratio for sine. For cosine, the ratio for cosine is the adjacent side, which means the side that's touching over the hypotenuse. So if we look at an example here, cosine is telling us the type of ratio we're making, and A is telling us the angle. So we're going to start at A. To figure out the adjacent side, it's the side that's not the hypotenuse and is touching. But what I like to do, I just label my opposite and my hypotenuse, and then the one left over is always the adjacent. Because sometimes I think it's hard to tell which one's the adjacent because there's two lines that are touching A. So what I like to do is start at my angle and go across. That's my opposite. Go to my 90. Go across. That is my hypotenuse. And then the side left over is always going to be our adjacent. It's kind of nice. Well, we said the ratio is the adjacent side over the hypotenuse side, so it's going to be B over C. In the next example, we're looking at angle B. So we're starting at angle B. And when you're dealing with the same triangle, but a different angle, we said that my, oh boy. When you're dealing with the same triangle and the angle switch, something? Oh boy. The opposite, I'm just going to erase. The opposite, trying to drag it, and the adjacent, they just trade places. Okay? So to set up that ratio for B, it's just going to be adjacent over the hypotenuse. So A over C. And you might be a little overwhelmed right now. And we'll see an example here with numbers. That might make a little more sense. We're just trying to talk about where these ratios came from. The ratio for tangent is the opposite side over the adjacent side. So again, label your sides. Here, tangent in this example is telling us the ratio we're making, and A is telling us what angle we're starting from. So we circle A and go across. That's our opposite. So our 90 go across. That's our hypotenuse. And the guy left over is just our adjacent. So opposite over adjacent. A is labeled as our opposite. B is labeled as our adjacent. And we said it's really nice because we're still dealing with the same triangle but a different angle. The adjacent and the opposite trade places. So now, our opposite over adjacent, B is labeled as our opposite, A is labeled as our adjacent. We notice the ratios just flip-flop. We had A over B, B over A. That's how I do ratios and derived from. And you're not going to be given, you're kind of going to be given the ratios, but we have a helpful little tool to help us remember that sine is the opposite side of the hypotenuse. That cosine is the adjacent over the hypotenuse. And that tangent is the opposite over adjacent. Okay, I'm going to move on. I'm going to pause. Go ahead and pause right. Finish writing stuff down. And that little phrase is called SOHCAHTOA. How I like to write it to be even more helpful for you to remember, I like to do big S, and then a fraction, a C, and then a fraction bar, a T, and then a fraction bar, because the S stands for sine. Okay, and we said the sine was the opposite side over the hypotenuse side. Cosine, we said, was the adjacent side over the hypotenuse side. And tangent, we said, was the opposite side over the adjacent. So whenever I have a right triangle trig problem, I always write this at the very top of my paper. Okay? And we can use this to now actually set up ratios using numbers. So here, before we get started, it kind of tells us the steps to follow. We're going to first always start with your angle. Label your sides as opposite, adjacent, and hypotenuse. And then if we're just finding the ratio, you write the ratio, and remember, always simplify. You want to make them a little note. Simplify the fraction. That's really important. So for an example 1, it says R16. I'm going to go ahead and label that right now. So R16, so I'm going to label that side 16. It said S is 30. So I'm going to go ahead and label S is 30. And then it said T was 34. So I'm going to label T as 34. Put those measurements in there. Okay. And it's saying find the sine, cosine, and tangent for, and the first one is angle R. So we're finding the sine, and we abbreviate sine. It looks like sin. That's how you abbreviate it, but it's actually pronounced sine. This is an abbreviation. So we're finding the sine of R. We're going to find the cosine of R. And we're going to find the tangent of R. All three ratios for that angle. So follow those steps above. Number 1, we're going to start with our angle. I like to circle it. That's my angle. We go across That's always our opposite. Go to your 90, go across. That is always your hypotenuse. And the guy left over is always your adjacent. Well, again, when we look, we know we're making the sine ratio for angle R. Well, go here up in SOHCAHTOA, sine is the opposite side of the hypotenuse side. We labeled 16 as our opposite, so that's going to go on the top. And we labeled 34 as our hypotenuse, that's going to go on the bottom. Once you make your ratio, always simplify that fraction, and 16 over 34 simplifies down to 8 over 17. Now we're going to make the ratio for cosine. So we're making a ratio for cosine. Go to C in SOHCAHTOA, that's telling us adjacent over hypotenuse. Well, we said 30 was our adjacent, and 34 is still our hypotenuse. And then again, simplify your fractions. 30 over 34 simplifies down to 15 over 17. And then the last one is tangent. We're making the tangent ratio, so we're going to go to T in SOHCAHTOA, and that says it's the opposite over the adjacent, O over A. We said our opposite was 16, our adjacent is 30, and when we simplify, 16 over 30 simplifies down to 8 over 15. For B, we're pretty much doing the same thing, but we're using a different angle. Now we're going to make these same ratios for angle S. So for S, we're making the sine of S. Some different colors in here. We're going to make the cosine of S. And we're going to make the tangent of S. So, we're dealing with a new angle, so we're going to start with a new angle. We're going to start with, come on, smartboard. There we go. So now we're starting at angle S. We're going to label angle S. We're going to have new opposite and adjacent because we're dealing with the same triangle, our hypotenuse is staying the same. Remember, we're starting with a new angle, so our opposite side is now 30, and our adjacent side is now 16. So when you're dealing with the same triangle, but you're making ratios for the other angle, the opposite and the adjacent just trade places. Well, for sine, again, we're making a ratio for sine. You go to the S in SOHCAHTOA. O stands for opposite, H stands for hypotenuse. So now it's 30 over 34. And 30 over 34 simplifies down to 14 over 17. Next, we're making the cosine for angle S, and cosine is the adjacent over hypotenuse. So we said our adjacent is 16, our hypotenuse is still 34, and 16 over 34 simplifies down to 8 over 17. And then the last one for S, we're making the tangent ratio, and tangent is opposite over adjacent. Opposite is 30, the adjacent is 16, and 30 over 16 simplifies down to 15 over 8. And again, you can use your calculator to simplify those fractions if you need to. You might be noticing some things, some patterns. We'll go a little more in depth with those patterns at the end of this unit. So you might be noticing some things about the sign of r and the cosine of x, and the cosine of r and the sine of s. Then you notice the tangents of the two angles are flip-flopped, and we're going to go more in depth with that later down the road. For right now, just focus on labeling the sides and setting up the right ratios. If you need to watch them again, feel free to. If not, go ahead, get started on your practice.